This is the panel on trillions of lines of code and counting, securing applications at scale, with your moderator, Adrian Lane.
Good morning. Just a quick reminder, I know they probably told you in every single other session today, or yesterday as well, to turn off the cell phones if you could. But yes, this is trillions of lines of code and counting, securing applications at scale. Our panelists today, we've got 4 great panelists, everybody deep in knowledge for code development and code management. On the end, we have John Johnson. He's a security manager for John Deere, manages security across 130 business units in 160 countries. Noted panelist, speaker, blogger. We're very thankful to have him on the panel today. Next to him is Alex Hutton, many of you know. Alex today asked me to introduce him as just a guy interested in risk analysis. That underserves him a little bit. You might know him as one of the co-authors of the Verizon data breach report. I know him as the guy most likely to ask for a cocktail waitress on the panel. Jeremiah Grossman's next to him, CTO White Hat Security. Probably no introduction necessary, just simply one of the best minds in the entire world on web and application security. And here, Brad Arkin. Brad Arkin is a director of product security and privacy at Adobe. He leads the secure software engineering team, formerly of Symantec, AtStake, and Cigital. That's our panel. I'm Adrian Lane. I'm with a small security analyst firm called Securosis. They've invited me up here because I've been professionally coding since 1987. I've been the CTO or VP of engineering of 4 different startups over the last 12 years. So we look at security under a microscope when it comes to applications. We look at tools, techniques, processes, and so forth. What we want to really focus on here today is the macro scale of securing applications. I've had this discussion with most of our panelists over one time or another, and I actually argued that we really could secure these applications. We could do things to train developers. The statistics have proven me wrong over time. So what I wanted to do is I wanted to ask the panelists, and I know that Alex and Jeremiah both have performed research in this area. Can you kind of frame the problem for us? I mean, how big of a problem is this? Is it getting worse? Maybe we start with John.
Is on.
We're off to a roaring start, guys.
Well, ask the question in a way that I can answer from the corporate perspective.
Okay.
Let me start. I'll start.
You start.
Okay. So I can talk.
Well, I don't even know which ones. Now both are on. I can talk from a perspective of actual incidents and what the role of software and software flaws and so forth play in actual incidents and pervasiveness. And then I'll hand it off to Jeremiah, and Jared can talk about the data that they see about how prevalent it is. Basically, we do a report at Verizon. When I was there, I'm no longer at Verizon. And the report is a summation of 1,700 incidents, and it's all the big ones and a lot of the little ones and so forth. And guess what? SQL injection, still huge, especially in incidents of magnitude. An incident of magnitude, by that I mean an incident where it really, really hurt the company. So yes, it's a big problem. It's a persistent problem. Yeah, I said persistent. If you have your buzzword bingo, you can knock that one off. And it's disturbing.
Like Alex said, Alex and his former role at, I guess, Verizon to look at the incident data. Who's attacking who for what reason and how. At White Hat, we take just a different perspective. Our job is to assess websites, that small software security problem called web security. When we assess websites, we're up to a little over 4,000 now, but I want to, while it sounds like a lot, it's really a microcosm of the web. Right now, there's about 1 million plus websites that have SSL certificates of some kind, so that gives you a notion how many important websites are out there. And even amongst those 4,000, 7 or 8 out of the 10 websites we test have something seriously wrong with them, and usually for most days of the year. So you look at it, many of you were probably pen testers, and think about it for a moment. How many vulnerabilities you're finding in these websites that could potentially be exploited, and they'll multiply it by 1 million, and that's how many vulnerabilities exist. So somehow, some way, we're going to have to find them and fix them. And the question is, how do we go about doing that? That's one of the strategies. How do we go about finding them and fixing them? And hopefully, as we build the next generation of the web, maybe call it Web 2.0 or something like that. How do you? Did I get a buzzword? Oh, God. How do we make the next version of the web have less vulnerabilities?
So let's turn this into a business context then, and I'll start with Brad. So you manage security teams in software development. Where do you start? I mean, how do you begin to address the problem?
So for us, the first step when we look at the problem is, and we describe it as raising the security IQ across the company. And so where we begin is with education. And so if you go to a product team and you convince them that they need to do more for security and they don't know where to start or what to do, then it's unproductive because you just induce panic and nothing happens afterwards that's going to help the problem. And so education for us is the most important place to start. And then quickly thereafter, you have to work on aligning the incentives and making sure that you have a way to measure if we're doing good enough or if we need to do more or reel it in a little bit. So that's, step one is education. Step two is making sure that you have some framework that'll drive attention to this problem and make it a priority. And then after that, then you quickly have to decide how you rank the risk according to each of the different business drivers that you have, and then what is most important, and start to determine what is going to be good enough so that you know how far you have to push until you get there.
So you're treating this as a corporate-wide problem?
Yeah, well, so we've got at least a couple of different specific problems. So one is for a lot of the code that we write, we don't actually operate it in production. So it's code that we put into shrink wrap boxes or people download and run in their environments. And so we need to make sure that we understand what the threat landscape looks like in the uses where it's being put into production, and then make sure that we engineer it to the appropriate level for that use case. And then the second problem that we have is the code that we write, which we host and operate ourselves. And so these are websites or services like Omniture, and making sure that we understand what types of risks we're facing in production in our own environment is another problem. And then when you look across all the products and services that we offer, there's about 300 major brand names there. Some of them matter a lot for security, so things like Adobe Reader and Acrobat, and some are less so. So the world doesn't communicate through paintbrush files, and so malicious paintbrush files aren't as big a threat to Photoshop users. And so there's certain things that are more appropriate that we do for some products and less so for others.
John, you want to pick that one up also?
Yeah, sure.
Where are you starting?
I think that a manufacturing company like like mine certainly has a different focus, and we have different customers that we're working towards. We have probably longer development cycles, fewer angry customers, and we may be a little bit slower. We're probably more like the Titanic turning at times, but I think education, like you said, Brad, is really important. Educating the developer community. We have a lot of offshore developers, and educating, and developing standards and educating management. Getting the business to buy into security as part of the total cost of ownership. Did I get a point? Okay, I didn't get one there. So, and that's very difficult because traditionally, security at a corporation is not something that, maybe we consider that you have to keep things better patched now from a network security vulnerability standpoint, but in software security, in some industries, we're still moving at a slower pace, and barring a digital cyber Pearl Harbor, we would really rather not have some kind of a big event drive the security budget, and so it's really demonstrating that there is a problem, ratcheting up, expanding the assessments and trying to push security down further into the QA process, so we can do it earlier on instead of after the fact, which is frankly where I think companies like ours have to start.
So I want to challenge the panel a little bit here, because the first couple of responses sound like the same thing I've been hearing for a few years. And I visit a lot of Fortune 100 companies. We're talking 30-year-old legacy applications, new web applications, older hub and spoke applications that got webified along the way, and quite literally millions of lines of code that are insecure. And education is great, but if that's the case, how are you educating these people? Because the software developers are not getting trained in college. I mean, they do not train software developers in college to create secure code. So what is your process to go about this education? Which pieces of education? Where are you guys starting?
So the way that we've approached education is through our certification program. And so this is something that my team has developed. We went out and looked at a lot of vendors, different training programs that were out there, and decided none of them were a great fit for what we needed to do. And so we put together this training program that is mainly based on computer-based modules, so people can take them. They're 20 to 40-minute segments, and it totals up, maybe there's 4 dozen in total. And in order to make it a little bit more fun for people, we divided them up into different belt levels. So you have white belt, green belt, brown belt, black belt. And so you can sort of unlock these milestones. We have an internal, sort of like an internal Facebook corporate network that you can connect to other people that you're friends with in the company. And so we call it Flare. So once you achieve a different level, you get a badge on your page. And so that's a way for people to know what levels they have achieved and show off about it. And by making it a little bit more of a competition, what we found is that there's a lot of people, particularly outside the U.S., so lazy Norte Americanos don't like education as much, but these folks really chase after getting certified to higher levels. And so we rolled this out on a voluntary basis, and we've got on the order of 5,000 or 6,000 code writers in the company. And then in the first year, we had about half of them had gone through at least to the white belt level, and a lot of them to the green belt level. And since then, we've been nudging that up close to 100%. And what we find is that you put compelling information out there, and some of this is dry stuff like C++ coding errors, and some of it is more interesting, like what happens in a PCERT response, and what are the bad guys thinking, and what do we need to get the information out in order to protect against. But if you make it interesting, you make it accessible, and you put it in the bite-sized chunks that are a better fit for their real workday, instead of asking them to take a week off and go somewhere for a training class, then people really soak up the information. But then to your point about that we're just saying the same things and that nothing has really been getting better the past 10 years, to me that's really the second part, which is how do you make it a priority? And so management wants to see that it's on time, on budget, it's going to work in production, maybe uptime's really important or performance. If security isn't one of the top very small number of priorities for the project, then it gets buried with all the rest. And so they're not going to focus on it as much. But when you make security a real priority, then you get the investment, you get people who are chasing down to figure out how to solve these hard engineering problems. And we find that things really do get measurably better very quickly. But it has to be a priority. That's the hard part.
Alex?
So I'll be the first to admit that I don't have great technical hacking creds. I've done a good amount of social engineering, and one of the things that was always ironic to me is a lot of security departments suffer, and a lot of security initiatives suffer because we have a wrong mindset. And I think education's the wrong mindset for all of us. How many people here would consider yourself positive around the term hacking, right? I do. I'm with that, right? So what we should approach this as hacking the system. And there's 3 systems we need to hack. Yes, we need to hack the developer community. I don't know how many of you have seen the card game that Adam Shostak did at Microsoft, The Escalation of Privilege. It's like Bridge meets Magic the Gathering, but around software security. It's awesome. And you can get it for free or you can order it for $20, but it becomes a drinking game, right? So you find one time a month where you can get your development teams together and you play a card game. But it's actually education, it's actually training, it actually gets them in the mindset, it's hacking their critical thinking skills as they go forward with that. So that's the first. The second is management.
but to actually hack at management to get better software security in the SDLC, you have to hack the accountant or the GRC accountant complex, right? Because these guys have created an entire system of anti-language, right, to obfuscate, wedge themselves between kind of us and management. And if you can hack them into believing that software security is a priority and something that they can make buckets of money on, right, now it will start becoming an executive priority, in my opinion. So we have these three communities to hack, and I think that is a way to start.
Show of hands from the audience. How many people in the audience either have security awareness training programs or security programs to educate developers within their company? Oh, actually, quite a bit. So, yeah. So one of the things that I hear over and over again by a lot of development managers who are tight on budget, tight on time, is that, I don't want to train these developers to do secure code. First, there's no business alignment for it. Second, it's a lot of budget. It's expensive to do, and as soon as I train them, they go somewhere else and take a better job. Obviously, the counter to that is, that you could be untrained and stay. So really, with organizations, and a question for John, do you have currently in-house budget for this? Are you able to incentivize and to get developers trained on secure development techniques, security awareness training throughout the organization?
I wish we did have a big budget and a real focus on it from the software development lifecycle. The approach that I've had to take is education leveraging things that we have. And so a lot of companies start off with, network vulnerability management and testing and all of that. And you get a lot of data from knowing and publicizing. I've tried to market this internally, both to the developers, the application owners and the management. The importance of whether it's a SQL injection problem with a web app, or whether it's this open source code that you've integrated into something that you've developed for the company that you have to then support and patch. These are all vulnerabilities, and getting them used to a monthly cycle of, for the lack of any real better way of doing it to start off, I think has been pretty successful. We've really raised awareness, raised the bar at our company, and they know that there are vulnerabilities out there. And so if we come to them with a different type of vulnerability, then at the application owner level, they're going to take that seriously. Where we've had trouble is really, like you said, with the training, I like the Flare idea. I know some developers that would really like Flare. I'd love to see them with what are these little alumni things? We give them little hash marks on their arms or something, or tattoos. I don't know. I'm a good coder, but they're all just different ways of looking at vulnerable systems, and I think that corporations are doing a better job of going out there and it's not just patching Microsoft, it's patching all these weird third-party things and things that you buy and bring in and things that you find on the internet, and trying to come up with standards and address this. And the more we do of that, the more we can continue to just expand that and hopefully add good tools. I find it really difficult to internalize a lot of the, Alex was saying he doesn't have a real hacking background, and a lot of people in corporations, in corporate America, we don't have the budget to have lots of software security experts. So we don't have a lot of the expertise in-house, and one of the things that we need to do is to leverage industry reports, examples of other companies that have had problems, especially competitors, and to go out and rely on third parties, outsourced companies that have that do thousands of pen tests a week, that have real depth, and at a company like mine, we might have somebody who sees the matrix and sits there and knows all these things that are going on, and then they retire or they, go to another company. And in other countries, we really
that's
have
actually
that
a good
problem.
segue, because I wanted to ask Jeremiah a question along this. Because what I'm hearing the panelists saying is that training, education, awareness, and so forth, what I'm hearing in the analyst community is tools, 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 tools. Now, granted, a tool's often only as good as the person behind it. But Jeremiah, your company is one that's going to rely on both tools and training and the expertise of the people in-house. So, I mean, what's the program like within your organization? Where's the balance point?
Sure. So developer awareness and developer training is an amazingly vexing problem. Just, if nothing else, but consider the scale, not just software security experts, but, with developers too. There are 17 million or so developers in the world. I doubt even 1% have had professional security training. How do we train 17 million developers that are pumping out secure code all the time? And then we have this mobile thing where I don't even know if we call them developers who are writing these applications now. And so let's say you have 17 million developers, and let's say you're doing on-site training. Who are the trainers? Even if you have a 1% ratio, we have nowhere near the trainers. So we're going to need clear technological solutions, processes, software to do, computer-based training for software security. But that's, that's the how. It doesn't really address the motivation. To Brad's point, you have to be motivated to want to develop secure code, and that's management down. So, to Adrian's question, how do we do it internally? The software expertise that we primarily require internally is the ability to break websites en masse. And so the only way we've been able to figure that out and do it at scale is to segment out the vulnerability assessment process into discrete units, the things you can automate, the things that you can't, or pseudo-automate, and break those down into discrete work units so you don't need security pros to figure out how to log into websites, fill out forms, or verify cross-site scripting, because that's been the unscalable model of the pen test world, is that you need one person that knows it all. So you have to break it up into discrete work units, and then you just trial by fire. You let them, basically you get the get out of jail free card on thousands and thousands and thousands of websites, and they get really experienced really fast. It's the only way we've been able to figure out how to do it at scale.
I just want to add to that. If your company thinks that you can buy a tool and push a button and the technology is going to solve your problem, then they're off base.
But if we're going to deal with the scale of the issue, there's got to be some form of automation there, right? I mean, there has to be some...
Automation is important because it's got to scale. Yeah.
Right. So if we're talking about
you
training 17 million developers around the world, I mean, there's got to be a balance point here somewhere. Because I'm hearing other analysts in the community saying, that the developers will never get there. It's the same problem. We can't fix the code simply because there's too much of it. We're not going to train the developers and get them up to speed for the same reason. So let's push the security down in the compiler layer. Let's bolt a WAF on the front of our website. I mean, that's what I'm hearing. And there's a much more compelling business case in many ways. To do that, because it's a fixed sunk cost one time that WAF box is not going to leave my company. So business alignment, I mean, Brad, maybe you take this question. I mean, the business alignment aspects of it, how do you incentivize the organization? How do you incentivize the developers to actually create secure code?
So I wanted to talk about the tools real quick. So we've seen tools to try to make the code better or perfect or bulletproof. Usually those things don't work in practice. But something that has been very successful are mitigation technologies which make the attacker's level of effort much higher in order to carry out an exploit. And so on the Microsoft Windows platform, you see things like DEP and ASLR are very effective in raising the cost to the attacker. And so the amount of time in front of the keyboard to take what would have been a vulnerable piece of code and convert that into a functional working exploit that's robust and reliable is now much, much more expensive for people who opt into these types of mitigation technologies. And so then with one of the Adobe products, Reader and Acrobat with version 10, we put in some sandboxing technology which leverages low rights mode on a Windows platform. And so even though there still may be juicy vulnerable code somewhere in the code base, it's now an extra hop in order to carry out a successful attack. And that's a lot more work. And so I think that there is a lot of future mitigation technologies and things in the compiler tool chain and the platform that can help a lot. But then to segue into the other question, making that investment to take advantage of these things or to try to do a better job in securing the code itself, it really has to be a priority. And that's going to be dependent on the business context of what the code is being written for. And so if I'm working in a bank, the arguments that I make that we should do more for security are going to be different than if I'm working, at a law firm or at a company like Adobe. So I've been at Adobe almost 3 years now. And when I first started, I cast a very wide net looking for ideas and motivations of what might really set the hook in order for us to get people to pay attention at the developer level to security. And we had pockets of teams and then individuals who are really passionate about security, but how do you make it a corporate-wide priority? And so I met with the corporate social responsibility folks. I met with the PR team. I introduced myself to a lot of folks very far outside of engineering in order to understand, what's your priority? What are you hearing from your customers? What can we do in order to make sure that the security that we're delivering matches the expectations and needs of the customers in their environment? And we finally latched on to a couple of things that really mattered to Adobe's business, and that is what we used in order to pivot up. And so now we have monthly meetings with the CEO where we get to present a dashboard about how all the product teams are doing. And when you get a red next to your product that gets shown to the CEO, it's not going to be red a month later. Things really change very quickly when you get that level of exposure to management. And then if the CEO ever gets a little bit tired, we have a standing slot at the board meeting in order to describe to the board members what we're doing there for security. And so that level of priority is what it takes in order to really make a big change, particularly when you've got so much inertia going in a particular direction. And so unfortunately, apart from the persistence that's required, these aren't easily repeatable tricks that work across every company because the business context is going to be so different. But that's, I think, one of the big things is just to start casting a wide net, looking for how to tie it to the business more directly.
So I actually want to take this and move the question over to Alex because based upon a lot of your research, that's pretty much industry-wide research. If you're going to take a risk-based view of where you're going to put your investment, what do you think? From the breach research that you have done, where would you make investments if you were on the outside looking in?
Assuming I'm not vendor specific, right? Like I'm not producing code that other people are going to consume outside of my walls. The data has reinforced what we have always known intuitively about threat modeling. You got targeted and you got non-targeted, right? And up to this point, targeted has meant bigger, awfuler breaches. And we all have sat in conferences like this for the past several years and heard, and there's nothing you can do about those guys. So in terms of automation, in terms of doing that, at least you can start to address, in terms of easy wins, the non-targeted, right? The target is much more difficult, and I think that's where we're failing wonderfully, and that's why we're having this sort of discussion, and I don't have answers around that. I don't think anybody does.
Why don't we go back to the justification of security? Many organizations have a tough enough time getting the developer headcount they need to fill out feature function development that they've got. Where do you come up with a budget? How do you justify the security spend? Obviously there's larger companies, Microsoft's got budget, smaller firms like John Deere, maybe not so much. So how do you go about getting the justification for security and getting the budget at it?
I guess compared to Microsoft, we're a small company. It's important that you market security inside your company and that you have buy-in from your upper management. And it's really important that you find out what it is that your CIO or your executives find important, because there's some aspect of security that is important to them, whether it's privacy or protecting intellectual property, or availability, or whatever it is, and take the marketing and present it to them in a way that is relevant to them. This is, I think, common sense.
Did I see a hand go up over here? We'll take questions during the session if you've got them. Just kind of speak up, use your Outdoor voice.
Adrian, when I talked about hacking the GRC accounting complex, this is exactly what I mean. So if you look at all the risk models out there, they are find an issue, then fix an issue. It's backwards to the concept of building security into software. As these guys are measuring and reporting up to your managers, it is that sort of thing that's going on. Adobe's a little different from what we're hearing, but in terms of how that is being reported in your average enterprise, right, it's backwards. And so we have to change the way that we look at operational security in all aspects of it and say, okay, here are the relevant metrics. Yes, there is impact, and here's impact, but stop making fake likelihoods, stop making fake probabilities, and start focusing that we can be proactive here. And we know by the data that if we do a good job with software security, we can at least do a good job at making sure that the non-targeted types of attacks, right, we can survive those, we can resist those.
So,
Question?
Yeah, what do you see as the role of programming languages? How much better can we do than C++ and PHP?
So the question is, what is the role of programming languages in code security, and how do we improve C++ and PHP? Is that what I heard?
Or how much better can we do that than those?
How much better can we do than those? And any of my panelists want to field this?
relative security being between languages, can we do better with the languages? I guess a couple of answers to those. One is when we look at web security from outside looking in, our statistics show that the differences between languages as far as relative security, the outcomes are very slight. There might be some differences between frameworks, but not necessarily languages. The major challenge that we run into is that security doesn't get to drive or even really influence the frameworks that are used before they get widely adopted. We're not getting to choose the iOS or the Xcode framework prior to its getting used, or Ruby on Rails or anything like that. All of a sudden, we're going to Alex's point, going to be brought in after the fact to help secure an insecure framework. And maybe we can't even choose which ones or select which ones are secure to begin with because we don't get enough time to look at them before they're used. I mean, there's a ton of frameworks out there that we could be looking at, most of which will never be used. We don't know which ones are going to be widely adopted. So we're always kind of playing catch up with that regard. I don't have a great answer other than it's really, really hard.
So I think that there's certain categories of problems which existed, particularly if you look at C and C++, that are just solved problems when you look at more modern languages. And so, classic buffer overflow types of problems in C and C++ can't happen in .NET or Java or pretty much any modern scripting language. And so the trouble is all of those more modern languages are still susceptible to all of the sort of web type of screw-ups that developers can make. And so I think that the experience of looking at how the modern languages solve some of the problems that we saw in C and C++ gives me hope that we can come up with new approaches which will address some of the common problems that we see in these language sets that we're using today. I don't know if I've seen a lot of active research that's going in a pragmatic direction on this. So that's something that's I'm a little skeptical if we're going to see anything imminent to be delivered. But I think that's going to be a big part of it is that when you look at the problem of the trillions of lines of code that have been written in C and C++ today, and you can't write even a 100-line application in C and C++ without having a lot of problems in there, no matter how many people look at it. And so getting modern languages which allow us to help cover up for human nature to make these little mistakes is something that's going to be a big part of the final answer to this problem.
Question?
Yes. Although you brought it up a little bit in terms of the application firewall, in terms of doing some validation before it gets to the application, and having that as a service before it gets to the application. What about standard services that applications and developers could use? Something like a single sign-on component that the application developer would not develop, but simply insert into the application. And other functionality that could be used, such as
Do you want to repeat the question?
XML schema validation for web services, for example, would be another example.
So to try to summarize that quickly, the question was about the use of standard components or libraries that do certain things like authentication and the benefits of that. And so I enthusiastically agree that that's a good approach. And when I was at AdState, I was in New York, so we did a lot of work with the banks there. And what the banks found is that they might have 1,000 different major applications in their portfolio, and they had 990 different implementations of a password storage mechanism. And they all had different credentials, and it was a real nightmare. And they found that everyone was doing it wrong. And so they said, well, this is ridiculous. Why are we repeating all of this effort across all of these different applications? So they extracted out the authentication mechanism, created a single password store, and made sure that they did it right, and they could focus a lot of attention on it. And then they told all the applications that by 18 months from today, you have to update your app to rip out your own authentication and use this single store. And that was really important for the banks in particular, because when they terminated an employee, they wanted to have confidence that they'd actually scraped out all of their access to all their systems. So that provided a real business benefit to them beyond just making things a little bit better for security. And it wasn't just authentication, it was entitlements and permissions, and they had a lot of other modules that were implemented by one team, done correctly, vetted very carefully, and then mandated for use across the whole company. And then we see things like OWASP has the ISAPI API, so there's some cross-industry efforts to do similar things. And I think there's a lot more opportunity to take advantage of this in the future because the chance to do something right once, or at least have a lot of people working on it, instead of implementing the same mistakes over and over again across different implementations. So that is, I think, a real trick for how we can make things better quickly.
I just want to echo that that's a great comment, and having a single method for web authentication has been very important for our company for about 12 years.
So is this a community problem? I mean, is this something that we really should be looking for the open source community and the like to really give us secure LAMP stacks, give us secure components, give us secure libraries? I mean, is that really what we should be focusing on to help solve this problem?
I don't think it's binary. I think that's a big piece of it. I mean, I've spent the last 5 years being the business owner for a really sensitive application that collects, incident data from LEAs. And I got to use some really hot-to-trot Rails app guys. And those guys just want to build Legos, right? They're not, oh, Jim here, Jim there, and boom, there's your web app, right? They don't care about the security aspect of those. But if the gems, and the code libraries they're using were inherently trustworthy, would have had a lot more trust with those guys.
Cheap, fast, and easy always wins the day, and we see adoption for many of these programs because they're freaking easy to implement. They can do it quickly, and so most of those are inherently insecure. They don't have authorization controls. They don't secure the data transfers. So my practical experience is very much in line with that. So what's not working? From your experience, I mean, what have you done and screwed up, and now you're moving forward? What can you give to the audience that avoid this at all costs?
I have a lot of anecdotes on this. So there's a few things that make sense at a project level, and they don't make sense at scale. And so my experience coming into my job at Adobe was working as a consultant, usually on a project-by-project basis, and occasionally working with a company for a short period of time. And I had sort of an attitude that I could march into an individual product team and sort of whip them into shape, and then things would be better afterwards. And so there's a lot of things around manual code review, testing, and security quality assurance. And these things may work, and it may be satisfying that you can by hand find a bunch of bugs looking at a certain section of code. But when you think about how much code exists inside of even, Adobe's not a huge company, but we've got on the order of 1 billion lines of code in all of our products. And so you multiply how many man years it would take to go through all that by hand, there's no chance. And when you look at it, any time you spend on manual code review could have been better invested on some other quality process. So we've spent more time on code review, which in hindsight I would have wished we hadn't. And the other thing is that trying to use test results to demonstrate a business need really doesn't help at all. So if you go in and you do some kind of pen test and then you wave the report around and you say, we found this many critical bugs and we found this many of this category of bug, and this should demonstrate to you that this is a priority. And they say, no, it just demonstrates that I'm going to throw this in the pile with all the other bugs I'm not fixing. And so unless someone convinces them that these bugs are not priority 3, but they're really priority 0 or priority 1, and just having a thick report on the table doesn't change any of that. So there is an important role for testing and pen testing, but it's not effective until you've got that priority in place where you know the results will be integrated and addressed quickly, or at least assessed and integrated into the rest of the bug fixing they have to do. So those are a couple of things. I could go on, so let me take a break here.
Can I just add on to that just quickly? A comment that, I think that you're exactly right. And we have this focus on technology, and we have this focus on, we're kind of reactionary. And if we're talking billions or trillions, billions and billions of lines of code, we have to assume that there are vulnerabilities out there. There are flaws in lots. It's guaranteed, and so we need to have processes to respond. We need to have something. Okay, what do we do when we find a problem? How do we address that quickly? Not do we just run around in circles? And so I think having processes and being prepared to deal with that because it's inevitable is important.
So to Adrian's question, what isn't working? And I think this touches on budgeting, which you covered issue, and risk management, which Alex mentioned. The way we do InfoSec budgeting industry-wide doesn't work. If you think about it, how IT business invests, you spend the least amount of your IT budget on networks, routers, switches. Then just above that, as far as your spend, you spend a little bit more on hosts and servers and desktops and things. And now if you collect all your developers and all the software that you write and the software that you acquire, that's by far the most that you spend on, by far the most that IT invests in. Now if you look at IT security and how IT security invests, to protect the investment of IT, you spend the most on firewalls to protect the networks, what you spend the least on, followed by hosts. You buy AV and IDS and things like that. And then you spend comparably very little protecting the applications which drive your business. Congratulations, InfoSec, you're 180 degrees out of phase with the business.
It reminds me of the Gunnar Peterson table. If you guys haven't seen Gunnar Peterson's table, he's listed every significant security challenge since 1995, right? And so it's cloud, it's e-commerce and so forth. And so he lists the challenge, and then he lists our response as an industry, and it's firewall SSL, firewall SSL, firewall SSL, firewall SSL.
And so if you look at how budgeting is normally done, you take what you budgeted last year, you go to BlackHat, and you find the today's risk, and you add 10% more for the today's threat, and you call it done. Right? How do we get out of that problem? We can sit here and have the best answers, but if there's no resources to go forward, losing battle.
Question.
Rant and.
For Alex, do you have any insight into how many of the companies that do in-house development and end up on the Verizon report have in-house security initiatives for developers?
Repeat the question, please.
The question was, in the data sets that we have for incidents and failures, how many actually have in-house development staff and so forth? That's going to be, it's a changing trend, and that's the nature of the report because it's expanding out. It's a very small proportion this time. Most of the enterprises that we do, we will describe their organization as relatively sophisticated. But I don't have an exact number of that. Now, if you look at the data set and you see the huge bulge around level 3, level 4 merchants this year, yeah, those guys don't got jack.
Jeremiah had brought up an interesting point. We both shared the vision that software development in many ways has mimicked the auto industry. The United States had basically invented software development in many ways, led the industry for a long period of time. We saw outsourcing happen. But with the auto industry, we saw a lot of companies do it better than we did. In fact, we are in many ways lower in quality, or have been in many cases, than competitors, which have opened up a door for them to do it faster, cheaper, and in some cases better. In software, we saw, especially the first tech collapse, a lot of software development go overseas. And we watch over the last 12 years or so come back to the U.S., outsource to another country, come back to the U.S., outsource to another country. We really haven't seen any fundamental leap in the quality or the security of software, no matter where it's gone. So is there an indication here we just don't yet really know what we're doing? Is this a process issue? I mean, we have not seen a fundamental change in progress in this area.
Yeah, so I think one of the things that I see that goes wrong in offshoring stories that end with a bad security outcome is there's very poor communication of the requirements up front. And so the product managers or whoever is scoping out what they're asking to get built offshore, they're very clear on latency, performance, uptime requirements. There's a lot of things that they can measure that they're very clear on. The wireframes are very clear. And so these things usually get delivered, and eventually they work it out to where the app that's delivered meets these specs. It's very hard right now to quantify security, and so you can't say this needs to be, a 73, and we're willing to pay for as much as the 85, but anything below than 65 we won't accept. And there's no way to measure security like that today, the way that you can measure uptime or other performance characteristics. And so I think a lot of people, when they're speccing out what they want to be built overseas, they're not able to communicate what they're looking for. And so, the word secure is really the most unhelpful word in a sort of a spec or a feature requirement. And so to me, that's, I think, where the biggest breakdown is. And then when you have everybody doing development in the same room or the same building or the same campus, then there tends to be a lot better sort of nonverbal communication around these characteristics that are harder to quantify. So I think that's the biggest breakdown there. But for teams that have done development offshore that I've been a part of, where security really was a very big priority, and they spent a lot of time communicating it and demonstrating it, and they made very clear what kind of tests they were going to do, then it is possible to deliver a good security outcome with offshore code. But it just takes a lot of effort up front to communicate what it is that you're looking for.
John, did you have anything to add to that?
No, that's the model that we followed, and we have competitors that have not been successful with offshoring, and we chose to extend our enterprise, and we have hundreds of developers in other countries that work for us and are a part of our team. And there's a big learning curve with understanding the culture, and the communication issue, I think, does add some complexity, but it's manageable.
So I guess maybe the follow-on question to that is how do you incentivize those offshore developers, and is it quite possible that you are disincentivizing them to do security?
There is the fear, the reality that oftentimes you train people in this area, and they add it to their resume and leave and go somewhere else. And so I think retention is a concern. I think incentivizing them is a challenge, but I think it mostly comes down to clear communication of setting expectations, and I think driving projects from a central place as opposed to having things too dispersed.
So what are the tricks I've seen now several, many times at organizations, large and small, actually mostly the large ones, is that they define their metrics, what things they want to get better, whether it's number of vulnerabilities per line of code, window of exposure, time to fix, and they get their metrics down and they publish them, a security scorecard, very similar to Adobe perhaps, by business unit, and they publish them internally so all can see. So what happens is you have a natural, I guess, competitive incentive. No one wants to have the worst software in the business. And all of a sudden you go from a mindset where security is chasing the development groups, where the development groups are coming back to security going, how do I increase these numbers incrementally and not be the worst?
Well, I think that could be applied to security metrics in general.
Question. So if I rephrase the question, why isn't the industry certifying the engineers in some sort of standardized way?
Well, certifying developers in a similar fashion to the way we've done with engineers. And engineering is a critical component of our business, and we have we have certified, trained, credentialed engineers. We have a mature QA process for engineering. We're very process driven. We have ISO standards, IEEE standards, and we have Six Sigma, and we don't have that same level of maturity on the software development side, and I 100% agree that's where we need to be, and I see us moving in that direction, but I would ask the rest of the panel what they suggest for how we get there.
So I can share some anecdotes about how certification has been very effective for us internally. So we developed our own certification, and we're able to go to a product team now, and we'll say, what you're trying to do is very risky, or you're in a high threat environment, and so you need 2 black belts, a half dozen brown belts, 75% green belts, and 100% white belts. And the engineering VP looks at the team and says, well, the white belts, I can just make everyone go through the training, but brown belts and black belts take a lot of time, and we don't have them. And I said, well, you need them because you can't deliver a good product without that level of security IQ on the team. And so then they look around the company, and someone who's really into security but working on a product where security isn't as big a priority, maybe they've achieved a brown belt, and now you have career mobility because that guy will go over and snag them and say, hey, come over to my team because I need you to do security, and that turns the hobby into a career accelerator. And so that's something that's really worked well for us, and we can actually measure sort of the density of security IQ across product teams now and assess whether they're really trained up to the standards that they need. So this has worked well in our environment. The trouble is that the definitions for our certification criteria, we got to decide. There was no wrangling, there was no vendor influence, there was no one trying to get in their technology as something that was important for the criteria. So I think eventually moving from what we've accomplished inside our tiny little environment at Adobe towards something that works across industry, across companies, is a noble thing to strive for, but it's going to take years because all of the wrangling and politicking and complaining that'll happen, which we were able to sort out just in a 30-minute meeting just because we got to decide. But if you have 100 different companies contributing to this, it's going to take quite a while. But I agree that the benefits of what you've seen with other certifications do translate nicely to security. It's just the trouble of how to achieve that globally accepted industry level of certification is going to be tough, I think.
Okay, so I'll be the negative Nancy. I see where you're going, and I like that. And my comment was going to be, cool, how do you make that not the CISSP? No offense to CISSPs.
Yeah, that's exactly my comment, too. Because, I mean, there's lots of security training out there, and there's some very bad developer training where there's not much of it. What's there? I've led a lot of different teams in software development, and there's very few good training courses for developers to teach them how to code securely. And most of the ones I've seen don't really give them the essence of understanding how to threat model and how to look at code as an attacker is going to look at it, and really give them a sense of how they should be, fuzz testing or integrating testing from a security standpoint within their own development practices and life cycles. Question up front.
So I had a thought, which is only that. When you were describing comparing software development with auto manufacturing, I don't think software development is using a manufacturing model. I think it's using a literary model, in that 17 million people are each writing their own story. And that's why we're having so much trouble standardizing it, controlling it. When you said 17 million people, I thought, God, we have to stop those people from developing.
So the statement is that it's a bad analogy that we're not using the automotive production model. We're using a literary model, and that everybody's writing their own individual story, which is a good point. Processing communication and how this weaves its way through an organization so that people are actually building the right product and building a secure product. We've seen software development life cycles actually harm that sort of development methodology to get stuff tested properly, to get it secured.
How many companies have a software development life cycle? All right. How many companies I forgot what I was going to say. The zombie confused me.
So
We had one more.
we got time for one more question, sir in the white shirt.
Based on your experience, what is the better adopted on the SDLC, the static code analysis versus the dynamic?
So if I heard the question correctly, it's based upon our experience, what's more effective, static or dynamic testing? Somebody on the panel want to take that?
Somebody in the business of both now. I don't compare them. I don't compare and contrast them. I will not say one is better than the other. They both measure two very different things. Generally speaking, dynamic analysis is designed to measure the attacker, the hackability of an application, because they don't generally have the source. Static analysis is more based on defect. It can get earlier in the application before it's capable of running. So they will both overlap slightly in the things that they're able to find. So static analysis, you get early defect reduction. Dynamic analysis, you get hackability metrics. So just different measuring sticks to get more secure code.
So one thing that we found is that the most important thing for developer morale is that the tests are repeatable and consistent. And so there's nothing worse than if you have a human tester come in, they find 8 bugs, and then the developers go and fix them, the human tester comes back, finds 8 more bugs, and then the bug count never goes lower. They get very frustrated with that process. So anything that's repeatable, so that they can feel like they're making progress and they're really chipping away at the problem. And it's okay if you do that for a while and then you like recalibrate the testing so that there's like a new set of bugs to look for. But they really like to see that their effort is chipping away and driving down the bug counts.
And with that, we're going to close up the session. Thank you very much for the panelists and thank you, the audience, for coming.